You guys see that? Okay. Hi, welcome. We are FTC team 14365 of the Summit Nights. We're in Cincinnati. This is, let's see here. This is our third year competing as a team. So we have a little bit of experience, but we're really happy to be here presenting to you guys. I am Jack Crane. I am our team lead and the build lead.
I am Logan Miller. I am the team co-lead and programming lead, and I started last year.
I am Ari Barnes. I am the business team lead, and I just started Summit Nights last year.
And Alexandria McDillon is not with us today, but she is our outreach lead. So just again, welcome. Happy to have you here. We'll give you a quick introduction to the history of our team. Kind of touched on that in the introduction. We started 3 years ago for the Rover Ruckus season. We actually went to state that year. Last year we didn't go to state, but we still had a great year.
So some goals for our team is to make it to state possibly this year, to kind of build together as a more solid team and as a community, to spread out in terms of like outreach, to better understand like the coding and engineering process as the team, and to just once again like have a stronger bond together as teammates.
So our first kind of the beginning of our tips here is how our team is organized. We've organized ourselves into subteams. So we have a build/CAD subteam, a programming subteam, an outreach/business subteam, and we have an engineering notebook subteam. And we do this for many, many reasons. It's fairly common on a lot of teams to do subteams, but we make a point for everyone to have a leadership role. So we have 4 different subteams. They're each led by 4 different people. And then even within that, every person has something that they can lead, they claim. So another thing that we do with our subteams is we have a low commitment structure. So while at the beginning of the season, you commit to your subteams, you say, I want to build for the majority of the season, I want to program for the majority of the season, etc. That's not locking you in at all. So people on our team are more than welcome to switch from build to program, back to build, depending on their interest, depending on their availability, depending on what their project requires at that time. So we try to make a point to make sure that everybody gets exposure to everything that they could possibly want to do. When you're starting your season, you need to think about several things, especially right now with COVID. You need to be thinking about how you want to meet, where you want to meet, when you want to meet, and things that you're going to need. So how, where, and when to meet is very much up to your environment right now. So how to meet is going to be if you can or want to meet virtually or in person or some kind of hybrid of the both of them. And a lot of that's going to be, especially if you're a school affiliated team, a lot of that's going to be dictated by your school. And by extension of that, where and when to meet will be also dictated by your school. So if your school is in person still, and you think that it'll stay that way, schools are a great place to meet if you're able to get space. But if you're worried about going remote, or if you are remote, trying to find a teammate's house who's willing to host at least tiny meetings, but have the resources there is valuable. You need to be thinking about when you want to meet. So that's primarily just up to the availability of the team. So, if you want to meet on weekends or weekdays or mornings or afternoons or nights or whenever, just try and make it so as many people can attend. And then especially early, I know it's really hard, but be thinking about the things you might need. Be aware that there's typically a 1 to 2 week lead time with a lot of things. And especially in the early parts of seasons, a lot of things will go out of stock. We talk about rev hubs or control hubs. Those are almost always out of stock at the beginning of seasons. Motors, game pads, those are always hard to find. And then just with your kits, with your rev kits or Go Builda, Andy Mark, whatever you're going with, just be aware that that will take a while to ship. So if you think about that, make sure you have those ordered maybe before you start with a lot of things if you haven't already. We start our seasons with a build design session with everyone on the team. So even people who are 100% programming, 100%, outreach or business, everybody starts the season on build. So we have a big meeting where everybody gets a ton of note cards, and we go through each challenge, and we say, okay, how do you want to accomplish this? And everybody draws as many ideas as they can come up with, no limits. We try to keep them sane, but as long as you think that it's a realistic approach, everybody's ideas are valued. Then we discuss them. We decide maybe 1 or 2 in each area to go into cardboard or CAD on. So a lot of times we'll do cardboard just because it's easier to do CAD on something that already exists. But once we're done our cardboarding phase, which is great so we can get our testing and kind of get sizes figured out, we'll go into Onshape and draw it out, and then we'll try and 3D print it pretty early on. Next is our programming strategy.
So with programming design, you can actually do quite a lot during the design process before the robot is even built. One of the most valuable things that you can do is go through the challenge, all the different ways you score points. Look at how you can score using sensors with this challenge, how you can use a sensor on this challenge, and just do that for every single point scoring opportunity, and see which sensors you can use for multiple challenges and functions as well, to try and get a scope of what you're going to need to do, how feasible it will be to do that. And then you can actually start working once you have the robot built and you have a really good base on what you're doing from there.
Next is our outreach design strategy.
For outreach, what you can do is early on in the season, get together with your sub-team mentor, with your sub-team leaders or some members who are interested in pitching out ideas for outreach. What is something that you can do that's very valuable is what you can do is create a theme maybe that you want to center your outreach strategies around. So say, for instance, if you plan on like mentoring or helping out younger children, you can maybe come up with ideas such as tutoring or giving out classes for coding or anything else that's like revolves around your community. So you can like spread your team message and your team, what your team does out more.
And then we have our game strategy. So when we develop our game strategy at the beginning of the season, this happens a lot of times before build gets kicked off. We will draw out a graph, and we do a big graph of the points available versus their presumed difficulty. And everybody takes part in this, whether they have experience or not. You might think that people who don't have experience in FTC wouldn't necessarily be able to give an accurate presumed difficulty reading. You'd be surprised, especially people who don't have experience might have maybe a different way of looking at things that would be good insights. So we get everybody on our team together and we look at each task and we'll plot them versus the points available, or with the points available and the presumed difficulty. So as presumed difficulty increases on the x-axis here, the points available should be increasing. If you draw your line of best fit approximate here, you can kind of decide what's a good, what are good challenges to go after and what are maybe not so good challenges to spend your time on. So you're looking at usually things that are going to fall in that green area. because that's going to be easier, well, at least so you think at the beginning of the season, easier to accomplish, but worth more points. So that's a good thing to draw out, and then to keep it up for the rest of the season. We have this available at every meeting, and every now and then we'll change it, we'll mess with it. Maybe something turned out to be a lot harder than we thought it was, or vice versa. So next, we have creating a team calendar.
So marking your tournaments and scrimmages, when those dates will be, or when you plan to do a tournament or scrimmage early, is really important, because it will help to instill a sense of urgency and get you in your mind have a better time frame of when you need to complete anything. It's also important to place hard cutoff dates before tournaments on the build, programming, and presentation, because that will help reduce stress and give everyone the time that they need to complete those tasks. In general, you should have build mostly done 3 weeks before a tournament, programming mostly done 2 weeks before a tournament, and the presentation mostly done 1 week before a tournament. That doesn't mean that that's that hard cutoff date, but you should have the majority done, so all you have next is just little bug fixes or tiny adjustments, really. So that will leave plenty of time for practicing driving as well as the presentation.
So for the weeks leading up to a tournament, you do want to work on your presentation. For your presentation, you can invite parents, teachers, school administration, et cetera, so they can be there to give you more of a better insight on what your team is doing. You can tell them exactly like what your team is doing, what progress that they have made, dates of the tournaments. And you also want to get lots of drive practice in. You want to get your human player, your coach, and your 2 drivers together, because that will be very beneficial during the tournament and in future like robotics team meetings that you plan on having.
And our last big one here is the engineering notebook. The engineering notebook is confusing, kind of to say the least, for new teams. There are not a lot of easily accessible, clear instructions for it, but that's kind of the point. Your engineering notebook should reflect what your team thinks, what your team does, how your team operates, all of that stuff. The engineering notebook is extremely valuable for all kinds of purposes. The thing that's most valuable for teams is if you want to look back on your season. At the end of the season, if you want to look back and say, oh, what were we thinking at the beginning of the season? Or, you hope not, but maybe you want to get your engineering notebook to a point where if something goes catastrophically wrong, you can kind of go back in time and look at how you got to that stage. But the engineering notebook is a bigger asset to first. So when we show up to a tournament, hopefully we'll be doing that this year. When we show up to a tournament, they don't have any idea how our season has gone. They see a finished product in front of them. So what the engineering notebook is able, or gives us the ability to do, is convey how we got to that stage. And we can create our engineering notebook in such a way that it shows the journey. If we write at the beginning of the season, we write about how we came up with our ideas, and then 2 weeks later we write a detailed description of why they worked or why they didn't. That's really, really valuable for us and for First. And then there's also the engineering portfolio that's been created this year. The biggest difference between those two is the size. Routinely, engineering notebooks are hundreds of pages long. The engineering portfolio is meant to be a relatively short snippet of how your season has gone. And it's kind of just meant to portray the quick bits of your season. So you're looking for your engineering portfolio to show just the small, kind of maybe a timeline or the simple stuff, but you also need to have your engineering notebook ready because they might be asking you for more details, and you might want to show them kind of that day's write-up or that outreach event's write-up or some pictures or whatever that the engineering notebook provides. Huge tip on the engineering notebook. I've done this. I've seen it done. Don't procrastinate the engineering notebook. Like I said, it is several hundred pages long, and it's too much to do the week before a tournament. So that is what we have. I know this is not a huge call, but we're more than happy to field questions if you have any. But that's kind of what we have prepared.
Good afternoon. This is Paul Smith. I'm from Ohio FTC. So very, very nice presentation. You talked about the kit that you bought when you were rookie team. What did you purchase, and do you think you made the right decision over which kit to go for?
That's a really good question. We decided to go the Rev route. We bought the Rev FTC starter kit, which comes in the big orange crate. And that came with kind of everything that we needed for that first season. We did buy some extra phones. We bought some extra controllers, extra hubs, and extra batteries. But that is a great starting point. That is beneficial because we have to use the Rev hardware. We have to use the expansion hub or the control hub. So you're already starting in that product ecosystem. You do need to be aware, though, that Rev uses metric and basically everyone else uses inches. So if you're going the Rev route, you need to be prepared to be creating some adapters, some structural pieces if you decide to use a faster go build a Yellow Jacket motor or that kind of thing. You know, an Andy Mark mechanism wheel. Those kinds of things are different and they don't really play nice. So that's something you need to take into account, is kind of how the complexity you want to build your robot. Rev is great for its simplicity, but as you start to grow, you might find that Rev becomes a little bit more complicated to deal with.
So in hindsight, did you make the right decision starting with Rev, or would you, if you were starting again today, would you pick another kit?
That's a really good question. I think we might consider going with the Go Build a kits. We are finding ourselves using a lot of Go Build a hardware, the Yellow Jacket motors, wheels, that kind of stuff. And it does play a little bit nicer with Andy Mark products as well. So for a brand new team, Go Build 'em might be a worthwhile option.
And what other, I think Rev, you have to like cut to length some pieces, right? What other equipment would a rookie team be advised to get to help them with their robot build?
The Rev stuff especially, a lot of times does need to be cut to length. A bandsaw is easiest to do that with, but we've used hacksaws before and it works fine. It just takes some elbow grease. So tools wise, if you're going with the Rev route, I would get hacksaw or bandsaw, and then just extra of the Rev tools, your 5.5 millimeter hex driver, your little Allen wrenches that come with it, especially the Allen wrenches. Those are easy to lose. So we went out and we bought a ton of them. And then we use our little nut drivers from Rev so much, they tend to get stripped. So we have several of those at our disposal. If you're going the Andy Mark route or the Go Builder route, buying some Allen wrench sets would be a good decision, because a lot of those have maybe different size nuts and bolts that you're going to want to mess with. We haven't had to cut any Andy Mark or Go Builda materials. Actually, we did. We had to cut some Andy Mark stuff. We used the bandsaw for that. That worked pretty well. We haven't had to cut anything Go Builda though.
Okay, I got one last question since the I don't know if somebody else wants to ask it, but this year, how do you, with all the remote activity, how do you plan to practice your presentations and do your gameplay practice?
So we've been fortunate enough that we, as a school, have not gone remote until this week. So this was our first full remote week. We were still at school on Monday, but they sent us home. And we are going to be out for a little while. So we're still kind of trying to figure that out. But as of now, just doing normal video conferencing for our presentations. And then we have the robot and some field materials that we brought home that we're inviting teammates over to use those, safely with social distancing and all of that good stuff. I know that a lot of schools aren't quite so keen on sending things home with teammates, but if you have that capability, that's a great resource because that means your season doesn't have to come to a grinding halt.
And have you found a place to put a field?
We do, yeah. We have a pretty open basement that we've set some stuff up in.
It's quite a challenge.
Yes. It is helpful though. The remote field is a little bit smaller, so you've got a little bit more room to play with.
Have you played with the scoring software at all? Was that difficult to set up if you have?
We have not messed with that yet. We have one teammate who has really stepped up to do the scoring, and he has, I think, downloaded it, but we haven't really gotten a status update from him yet.
I'll say a great presentation, yourself and the rest of the team. So thank you.
Thank you.
Thank you.
All right, we're team 5040. This is our 10th year as a team, so we've been around a while, but we're happy to present here. I'm Tess Jones. I'm in charge of our business team. We've got Andrew here, who's in charge of build, and we've got Jeremy, who's in charge of programming. So we're going to be presenting on running a team effectively, and one big thing is dividing up work. So the Summit Nights sort of hit on this, but for our team, we do programming, build, and business sub-teams. So for those of you that don't know, we're actually a really, really big team. Like we have like 13 members. So that's what works for us. And one really good thing to avoid is having a lone wolf mentality. The Summit Nights hit on this earlier when they were talking about how during their design process, when they had everybody suggest ideas, we do the same thing where like everybody suggests ideas and all our ideas are anonymous. So like there's literally been times in previous seasons where rookies have suggested the idea that ended up being our final robot. I mean, it underwent modifications as it was built and whatever, but like they literally suggested the base idea. So the lone wolf mentality never really helps anybody because the one person that's doing all the work is super duper stressed out all the time, and the other people on the team don't feel like they're being as big of a part of the team, and it just doesn't help anybody. And getting input from other people is always beneficial because they might have an idea that you don't. They might have a perspective that you don't, even if they're inexperienced. Like the amount of work that you put in is the result you'll get out. If you have one team member doing the work at every meeting and you have a standard 2-hour meeting, I don't know, that versus 3 people working, that's literally 4 hours. And that difference only gets greater the more people you have working. So it's super helpful. Communication is probably the most important thing your team can do for its success. There's literally nothing that should come above it. And that starts with every competition. You want every team member to know what to expect, what they're going to be working on, like who's going to be scouting, who during a typical year, who's going to be scouting, who's going to be driving the robot. You want to have all that figured out ahead of time, and everybody should know what's going on. And the biggest part of communication is build and programming. and we're going to hit on this later, but if both build and programming have their time split, so like establishing our goals and priorities ahead of time, you want to work backwards from a competition date, and you can say like, we're going to need this long for programming. So if you have your goal established ahead of time, like for programming, we aren't going to have an auto, but we want to have a completely functioning teleop, right? Like the driver controlled part of the match. Like you're like, we're not going to do autonomous for this competition, but maybe the next one, you're going to want to set out that block of time. And you also want to anticipate that things are going to fall behind. That happens. Our team has already fallen behind once this season. Like it happens. Obstacles happen. Something doesn't go the way you want it to. That's going to happen. But by establishing your goals and planning for that, you avoid like everybody working in the entire week before a competition and not sleeping enough and not having time for homework. Like you want to avoid that. And some really good tools that we've used are, for one, Trello. And the screenshot is kind of small here, but basically Trello is like online post-it notes. And there are like a million different services out there, but this is the one we use because it's free and it lets you have like multiple boards. But you can separate them into columns for organizational purposes. So that's been super helpful for our team this year so that we can, especially with being online due to COVID, because a lot of our meetings are held online now, we can have everything so that team members know what they should be working on and what might be coming up. Another tool that we'll talk about later is GitHub, but it can be super useful for organizational purposes, but our programmer will talk more about that later. The next thing is called a sprint system. This is part of a larger thing called Agile Scrum that we're not going to go into because it's like overkill for most rookie teams' needs, and it's a lot to figure out, especially this late into the season. But basically, sprints specifically mean like every 2 weeks, you should be checking up on your goals. So like a 2-week increment we found is a really good measure of time for how long something should take. So if you're saying we want to have a drive team at the end of 2 sprints, right? That's 4 weeks. You can check in at each 2 weeks periods, and it's a really good tool for planning. And so we'll assign things to different sprints. And this kind of goes hand in hand with what we use to keep those organized. It's called a Gantt chart. And there's also group chat apps, and those are just helpful in general for communication purposes. But if you can go to the next slide, they can see like the full on. So basically a Gantt chart, we say like, if you see our sprints here, we can say like, so the first block is builds tasks. So prototyping, build a drivetrain, build an intake. And these goals will vary from team to team, but we can set aside a period of time we have them separated by meetings, by dates, and by sprints, so we can say this is how long we're expecting each thing to take. And it's a really good organizational tool because you can see everything laid out visually and everybody knows what's going on. And you can see we have it for programming, and it's hard to see on a screenshot, so I didn't get business in there, but it's a really useful tool.
So I'm Andrew. I am the build team lead on 5040 this year. So some general, some general building tips I have written out here. My first tip would be the acronym KISS. Keep it simple, silly. Basically, you implement this acronym a lot when you're designing parts, when you're designing mechanisms. Essentially, what it means is that if something is super mechanically complicated, it might not be the greatest thing to go after and pursue. In some instances, it could be, and there are multiple examples of teams that go with the more mechanically complicated option and have done well. But in general, especially when you're a rookie team, you want to make sure that you're managing your time and your resources wisely. And part of that would be implementing, thinking to yourself, is this simple or is this too complicated? An example of this would be when you're like prototyping, you want to make sure that, or actually when you're more designing the mechanisms that are going to go on your robot, you want to make sure that if any given part on the robot breaks, does it take forever and a half to take apart your robot, replace one motor, and put the entire thing back together? And if that is true, you want to see if you can design your robot in a way that is easy to maintain and fix parts when they need to be fixed. When you're in a competition, you're not going to have, and it's different than virtual competitions, but when you're in a physical, like in-person competition, you're not going to have a lot of time to take your entire robot apart just to fix one thing. So you want to make sure you design and like take into consideration that if you keep it simplistic and you keep it easy to maintain, you're going to have a lot better time when it comes to repairing and maintaining the robot. Tip number 2 would be expect setbacks and plan with them in mind. Going back to the Gantt chart, you have to, or it's recommended that you have an amount of weeks that you can use as insurance, because it's inevitable that you're going to run into setbacks, run into these potholes, and being able to plan ahead and start planning from your end goal and move backwards, you can incorporate an amount of time that allows you to catch back up, to be back on the track of things without having to go behind schedule. I'd also like to point out that there's no such thing as a robotics season without setbacks. You are always going to run into setbacks, whether you think you will or not. So you got to really make sure that you're ready to hit those potholes and you're ready to just keep on trucking along. My third tip would be always ask for other perspectives. It's invaluable to make sure that you have other people's opinions and other people's design ideas, because one person, again, the lone wolf mentality is not going to cut it. Having one person design an entire robot is not as efficient, nor is it as representative of the collective team mentality than it is to have a team working on designing the robot and having multiple different opinions coming in all over, so that you guys can combine it together and have a lot better of a robot than it would have been if one person spearheaded that idea and just completely went through with that whole design. Because you could that person could also get burnt out. And to avoid that, it's really easy to just have more than one person working on designing and have multiple perspectives when it comes to designing. My fourth point is use the community to your advantage. I have 3 examples here. I have the FTC Discord, the FTC Reddit, and the Game Manual Zero. There's a multitude of online resources that you can get information from, such as the FTC Reddit and the FTC Discord are kind of similar in a way where they're both these treasure troves of just knowledge that you can just go onto them. For the Discord, for example, you can go onto the Discord, you can ask a question, and teams from all over the world can see that question and they can respond to you and they can tell you, this is the problem that we faced. Here's how we would suggest solving that. And you can also get it down to regionally. There's Discords for FTC for your region, like Ohio, Cincinnati. You can get down to a very small regional area and you can have these questions answered by people with a lot of experience. And that's the same with the Reddit. You can find people that have asked questions that you might be wanting to ask. You can also ask your own question and someone can respond to that and answer that for you. Game Manual Zero kind of ties into my next point, which is being familiar with terms. By being familiar in terms, I mean be familiar with the tools you're going to be using, the companies that you're going to be getting your parts from, like GoBuilda, Tetrix, Rev, and being familiar with the mechanisms that you're going to put on your robot. And that's why I have Game Manual Zero here. Game Manual Zero is a website that you can go on, and it has all of this information about all the mechanisms that you would really find on a robot. So it's not just this is a drivetrain and this is what a drivetrain does. It's more of like, here's the multiple different types of drivetrain that you might come across and might want to build, and here's the pros and cons of each one. And that's the same for almost all of the other mechanisms you're ever going to find on a robot. So Game Manual Zero is a really good place to look if you're not sure, what is a virtual 4-bar lift. You can go to Game Manual Zero and it'll show examples and kind of tell you the pros and cons of what that type of lift is.
So some general programming tips. My first tip would be use a virtual robot program if you want to. Before you have the robot built, this can be a great tool to practice programming and get some experience if you haven't programmed a lot before or programmed with FTC before. There's a great one by Team 8397 that lets you program it the exact same way you would program an FTC robot. And it's a great tool for getting experience programming. Next, I would say the FTC Robot Controller app has a lot of example code built into it. So you can see that when you have your app, this is where you write all of your team code. If you go to the top and you select the FTC Robot Controller, and then you see Java, and then that file there are a lot of files in there that each of those have example code in them that can range from just how to program a simple drivetrain to how to use vision code and Vuforia to find navigation targets. So there's a real range of code at all different levels of complexity in there. Next, GitHub. GitHub is a really useful tool for any team. Even if you're just a single programmer, GitHub is a tool for storing code and sharing code. So even if you're a team with a single programmer, GitHub can help you back up your code. It can help you manage versions of your code if you want to revert to an older version, or if your code gets deleted, or if someone else wants to look at your code or even work on the code. It's a really good tool for collaboration and backing up code. Next, I would say comment your code, choose meaningful variable names, and make meaningful commit messages. If you don't know, a commit message is just a short bit of text you can write when you push code to GitHub. So all of these things go together to help make your code more understandable to other people and to yourself. So if other people want to look at your code and understand what it's doing, this is all really useful. Or if you want to go back to your code after you've maybe not touched it for a week and you need to understand what it's doing, all of these things will help you make that code much more understandable. Finally, I would say use the resources available to you. So this could be the FTC Reddit or the FTC Discord, but it could also be just Google. A lot of programming problems, if you're having an error, if you want to figure out how to implement a feature, anything like that, can be solved just by Googling it. Because if you're having a problem, chances are someone else has already experienced and solved that problem. So thanks for listening to our presentation. If you have any questions, ask them now, or if you want to ask them to us later, here's our Twitter, Instagram, and Gmail. And you feel free to contact us.
Great job, you guys. Quick question. You guys been around for 10 years. What do you see as the biggest challenge as you enter a new year on bringing new members on board?
Sometimes you can see this mentality in a lot of the more veteran members where it's like the rookie's point of view is not as important as a veteran's point of view, and that's not what we want. It's common to see that, and the way we combat that is, especially during our design process, we make sure that everybody's input is as powerful as anybody else's, because again, as Tess said, a rookie can have a very good idea and it can even be implemented into the robot. So we don't want to shoot down those ideas and act like, just because you've been on the team for a longer time means that your ideas are the best ones. We want to make sure everybody understands that we're on an equal playing field.
Great, thanks.
So we saw in the last presentation a chart that said points available, ease of difficult, degree of difficulty. So given this year's game, for a rookie team, what do you think the 2 or 3 things they should focus on? Whether it be the robot game or something in the outreach side?
I mean, I think the biggest thing is learning, obviously, but one thing I would say definitely, I mean, we count it as a component every year when because we do a difficulty versus payout chart, like in the beginning of our design process. The big thing would be make sure you have a working drivetrain. That's the really big thing, because without that, you really can't accomplish any of the other things unless you want to go crazy, and like that's way too much work to make a robot without a working drivetrain, especially for a rookie team. So I'd say a drivetrain, and then you want to look at the game and say, like, what do we think we can accomplish? Because there are FTC rookie teams that come in and already have FLL experience, and maybe they'll say, we want to go for the wobble. We want to do that. That's our big goal. Like, but you guys might say, like, maybe for us, we think we should work on getting the rings into the low goals because that's a little bit easier than, I don't know, trying for the mid or the high goal. So you really want to look at your team and what you think you're capable of accomplishing. That would be my big thing.
I would say, especially for a rookie team, it's extremely important to keep in mind that the season is not the most important thing. So going to Worlds, it's very unlikely that a rookie team will be able to go to Worlds. So you want to focus a lot on your outreach and a lot on building that financial foundation so that you can go in the years on from that, have the ability to execute more complicated and more, crazier designs, not crazy in a bad way, but use materials and use resources available to you that you might not have available to you when you don't have the financial ability to. So building up your outreach, getting your name out there, establishing a really solid connection with your community, and making sure you can secure some sponsorships and some grants and things like that so that you're capable of going above and beyond in the years that follow.
So when you design a robot, do you design it for the first qualifier or the last qualifier? In other words, how do you keep real estate available to add features on later on? So, or do you kind of just take it as, take it by each qualifier it comes up?
So we try to design for the first qualifier because what oftentimes happens over the course of a season is you'll see other designs or you'll just come up with new ideas as the season progresses, and you don't really want to box yourself out because you decided something at the very beginning of the season. So we end up planning for the first qualifier, and that also kind of builds into the Gantt chart and the working backwards aspect, because if you know exactly what you want to have when you go to compete for the first time, it makes your prioritization and everything just a little bit easier to do. And you can almost always change stuff later. And if you can't, you want to really focus on building kind of a modular robot where each segment of the robot is its own kind of, not self-contained, but as self-contained as it can be, so that it's easier to take off and fix or just swap out for something else later on.
And you talked about drivetrains being something the rookie team should focus on. So how do you select the drivetrain for the given season? For example, this season, how have you approached that?
Well, there's a lot of the game manual 0 is a really good spot for learning about the different types of drivetrains and what would work for each individual game. But what we usually try to look at is like, what kind of movement is our robot going to be doing around the field, right? So like, if you use this year as an example, you're going to be driving around a lot to pick up the rings, put them in the bins. Like, you're going to be driving around a lot. So we were like, all right, we're going to have to move in a lot of different directions. So we narrowed it down. So like, we were able to get rid of just a drivetrain with like normal wheels, right? And a lot of this also depends on your budget. Like, if you can't afford like to buy nice mechanism wheels, then you might have more limited options. But like for us, we were like, all right, we're not gonna do 4 normal wheels because we're gonna have to turn a lot, and that'll slow us down. So we narrowed it down to like an X drive, which is omni wheels and an X formation that allows you to move in every direction pretty fast, and a mechanism drive, which is the special mechanism wheels, and they're the ones that have little special roller things, and they face inward, which lets you move back and forth really fast and turn pretty fast. And we said, all right, we're going to prototype that because we couldn't know from our design process which one would work better in the long run, and then we were like, all right, mechanism is better this year. And once again, the game manual 0 thing would be really, really useful if you're wondering which kind of drive change to do.
Okay, my last question will be on something a little different, but you mentioned budgets there and what teams can afford. Do you give any advice to the rookie teams on how to raise the best sources for raising funds?
There's a lot of rookie grants out there that you can look for to apply for that can be helpful. And a big thing for how to get a sponsor, especially early on, is local businesses. The more local you go, the more likely they are to sponsor you. And you really want to focus on those personal connections. So like if you have a mentor that works for GE or something, they might be able to come in and say, here, we can sponsor you for this much. And sometimes, even if they can't give you money, especially this year during COVID, a lot of businesses are being hit hard that would normally sponsor you for money. They might say, here, we can help you with this part of your robot or this part of your programming. But that local connection is really important.
And how do you go about looking for grants?
Honestly, I don't have much to offer here because we haven't been a rookie team for 10 years,
Yeah.
but
Well, again, another great presentation, and you answered all my questions.
Yeah, everybody did a great job.
It was wonderful. Thank you guys so much. Fantastic work.
Thanks, everybody. Good to see
Yeah,
you.
thank you for the opportunity.
Thank you.
Thank you.
yeah, thank you guys. This is great.